Yeah, this is great work. And the thing I wanted to add to it was, doing the analysis is sometimes the easiest part. Trying to graph it, because the whole idea is, well, the whole reason you're studying this stuff is to understand how functions look when you're trying to do things with them in calculus, right? So I thought I'd add to, like, how do you graph this? Because some people have a hard time um, completing this part. So we did all this gradient analysis, and so I know there's a vertical asymptote at x equals 2, so I'm going to put a little dotted line there. And I know there's a hole at -2, but I don't know where the graph goes yet, so I'm just going to keep that in mind, that when I come to -2, I got to remember I got to put a hole in the graph. I know that y equals 1, so that's the horizontal asymptote. I know it crosses the x-axis at x equals 3, so I'm going to put a point here. I know the y-intercept is 1.5, so let's see, that's 1, here's 2, so 1.5 is about there. So I think that's all the information I have. Now, what does this graph look like? Well, because I know that this basically becomes x minus 3 over x minus 2, this is like the 1 over x function that's been shifted to the right 2. And then, of course, it's got something going on with the y, the x-intercept, up or down or whatever. But what I know is, because this isn't a squared factor on the bottom, it's not like this squared. I know there's no fancy wiggles or bouncing at all. So I'm just going to, what I know it's got to go, I know out in infinity it's got to reach that line. I know it can't cross the vertical line, so that graph looks something like this. I know there might be another little wiggle in there. I don't think there is on this graph, but basically that's what we see. And then, because this is acting like 1 over x, this means this has to come down. It's not going to come up like this. Well, it's not going to come up for a couple of reasons. It doesn't cross the x-axis any other place, so I can't have a line there. Um, the other thing I'll do in a minute here, okay, let me get rid of that red ink. I'll graph to write it. So I know this has to look like this. Cross through there, cross through the y-intercept. Then it's going to approach that horizontal asymptote. So this is acting like the 1 over x function. It might be reflected. Yeah, it might be reflected around the x-axis, but that's what we're looking at. I'm going to do number what number? I'm going to do the next problem is going to have a situation where this graph is going to head in the same direction around a vertical asymptote. I, I hope you folks caught the mistake I did. I got so distracted with talking about how the axes work. But you see, what I forgot was the hole at -2. So technically, what I should have done is right there in that graph, I should have written a hole or something like that, because that x equals -2 is not in the domain of that function. Okay, so that's that. Um, Let me get set up for the next question. So here's number 50 on that same page. I'm doing this odd numbered exercise even though you've got the answers, because just in case somebody wants to post an answer to number 16, that they can still do that. I haven't done the work for them. Haven't robbed the chance for you to succeed with that. So I don't know how your factoring skills are. If you were with me in my high school classroom, I get to see you every day. You'd be doing mad minutes and get really good at this. So here we'll just do what we can. Hopefully somebody did that with you earlier. So when I factor, I do. Let's see, where's my pointer? Isn't there an annotated thing here? Oh, here it is. They moved it. I ask myself, what multiplies give me 3x squared? Well, 3x and x. And then I look at the 4, and I know one's going to be positive, one's going to be negative, and whatever I put here is going to get multiplied by 3. Whatever I put here is going to get multiplied by 2. So I think, okay, I need to get 4 in the middle. So 3 times 2 is 6, minus 2 is 4. So I knew it had to be like that. And it has to be a positive 2 here because I want a positive 4 there. And then the part that people get stuck on sometimes is the denominator. You're going to look for a greatest common factor. In this case, it's x squared, which becomes this. So now let's do some further analysis. Let's see. I don't see any common factors, so there's no holes. I see a vertical asymptote at x equals 0 and a vertical asymptote at x equals 4. Now, the thing that's different about this one is, you see how that's a squared factor? So the vertical asymptote at x equals 0 is going to act like the parent function 1 over x squared. That's the one where they head in the same direction. So it'd be like this, or it could head down to negative infinity. So on either side of that asymptote, it's going to head in the same direction. That's really the reason why I'm doing this problem for you. Okay, so let's get some more work here. Let's see. I know that it's a bottom heavy function, right? Because it's x squared over x cubed, so that tells me the HA is the x-axis, and then the y-intercept is, let's see, the y-intercept. Well, I know there's a vertical asymptote at x equals 0, so there's no y-intercept. And then we get two x-intercepts, don't we? So I know it's going to cross the x-axis at 2/3, and it's going to cross it at -2. Because I'm just in case you're wondering what I did, I set this equal to 0. I added 2 divided by 3. Maybe I should write that. 3x minus 2 equals 0. So I added 2 divided by 3. So x equals the 2/3. That's where I got that from. And then for this one, where does x plus 2 equal 0? Well, that happens at -2. Oh, good. Do we have everything? I see I got a HA, I got my VAs, I got the x-intercepts. I know where it crosses the y-axis, or it doesn't in this case. So then to graph it, and this is the part that often, like I said, gives people a hard time. So I know that there's a vertical asymptote here at x equals 0. I know there's a vertical asymptote at x equals 4. 1, 2, 3, 4. I know there's an x-intercept at 2/3. I know there's a x-intercept at -2. I know the horizontal asymptote is the x-axis. Now, some people will say, well, how can, if the x-axis is the HA, can it cross the HA? Remember, the horizontal asymptote is the long run behavior, the ending behavior. So yeah, in the middle here, it can cross it just fine. Now, a couple things I see. I know that um, it's got a, how's this going to look? I'm going to guess here in the middle. It's got a, well, let's make a guess. I don't know. This is what I'm going to start with. I'm going to say, okay, I know it's going to cross through that point, and it's got some kind of wiggle going on over here, and it's heading this direction. Now, if that's the case, so it's something like that. I don't know if there's a curve there, but I know it. I know it looks something like that there. Um, if that's the case, and I know that this is where it's supposed to act like 1 over x squared, if I graph this, that'll be able to cross through that and head in that direction. And actually what's going to happen, it's going to have to come back, curl back around, isn't it? So somewhere there's a curl. How about over here? Well, the way I graph this, it looks like it. No, actually, the way I graphed it, it's got to be opposite directions. See, remember, because this is acting like 1 over x. So this would have to, if this is going up like this would be looking like this, and it's going to come around and curl around. So I think that works. What if I had decided, because this is kind of like a magic thing I did here in the middle, right? I said I'm going to try that. Let's see if I can make this work going the other way. Probably I can't because there's got to be there's some other thing going on here. But, I could be wrong. Let's see. So, let's see, did I do everything? And then there's no y-intercept. I'm not missing any pieces. Okay, let's try it. So let me go to a different ink so I don't lose the other one here. Let's use green. So what if I said it's going to act like this? And because at x equals 0, it's got to act like 1 over x squared. It's got to come down like this. It's got to curl through there and head that direction. Just remember, because it's got to curl back. So I haven't violated anything there. Then over here, well, you know what? I don't see, that would work. So what we've got to do now is, I guess the only way to get around this is think about some other points. Let's see what happens. if I were to substitute in, because I don't really know which one it is, let's do something here in the middle, because that's the thing. If we have the middle right, all the rest follow. Let's substitute in. Let's see. That's it. That's it. 2. No, that's the 2/3. Let's plug in 1 because 1's a nice easy number to substitute in. See what happens. Now I could go back to the original, but I've got it all factored out right here. What if I substitute in 1? And all we really got to worry about is whether it's positive or negative, right? Because if positive, that means it's the blue graph. If it's negative, it's the green graph. So that'll become what? 3 minus 2 is 1, and 1 plus 2 is 3. And then the bottom I get 1, because 1 squared, and then 1 minus 4 is negative 3. And then we can see, yeah, that's going to be a negative value. So it has to be the green graph. Okay, and sometimes you need to do this. I mean, as you can see, there's 2 ways to graph this, so we need to check a third point to get it to graph. This was a good question. I'm glad I did this. It's made me think a little bit. Okay, so that's the process, trying to figure out how the graph goes. Um, wouldn't be a bad idea to do some more practice with this if anybody needs that help. And of course, if you need some help, give me a yell.